Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Neighboring group participation, NGP, in nucleophilic substitution reactions. Moving on to the next step. Identify the substrate. The substrate is a compound with a cyclohexyl group attached to a 14C labeled carbon-filled diamond, which is in turn attached to a carbon bearing the OTS-leaving group, no label, marked with circle. The 14C label is on the carbon adjacent to the carbon bearing OTS. Moving on to the next step. Understand the labeling experiment. The 14C label is on one carbon and OTS is on the adjacent carbon. When RCO2H acts as nucleophile, two products are formed, one where the ochre group is on the carbon that originally bore OTS, normal attack, and one where the ochre group is on the 14C labeled carbon, scrambled product. This scrambling of the label between the two carbons is the key observation. And for the final step, explain the mechanism via NGP. In SN-NGP, neighboring group participation, the oxygen atom of the ether hydroxyl or the adjacent group acts as an internal nucleophile. Here, the phenyl ring or adjacent group participates, the leaving group, OTS, departs while the neighboring group forms a bridged intermediate, episulfonium type or epoxide-like intermediate, creating a symmetrical or semi-symmetrical intermediate. This bridged intermediate can then be attacked by the external nucleophile, RCO2H-RCO- at either carbon, leading to two products with the label appearing at both positions. Why not other options? A. SN1. SN1 would give a carbocation, and while it could give scrambling, the specific two-product pattern with label scrambling points to a defined bridged intermediate, not a free carbocation. B. SN2. SN2 gives clean inversion at one center only, would not produce two products with label scrambling. D. SNAR aromatic substitution is not relevant here as there is no substitution on the aromatic ring. The two products observed correspond to nucleophilic attack at the two carbons of the bridged intermediate, which is characteristic of SN-NGP, neighboring group participation mechanism. Therefore, the correct answer is C. Therefore, the correct answer is option C.